Hello, this is the design project. My question here is to use a piezoelectricity material to solve for the transducer. So for transducer is basically just one piezoelectric material, and then it receives the voltage from the electric field and then produce the wave propagation. We want this component to have the least displacement because we don't want this to deform too much under a strong electric field in the transducer. And then because of the current flowing through this material, we don't want the temperature increased by that to change too much for this device. For simplicity, we just consider the piezoelectricity in the middle, and on the top and bottom there will be two plates. That's nickel as the surroundings. So to solve this problem, basically is just a cubic strip with the piezo in the middle and the two metals on the top and the bottom. We have the piezoelectric constitutive equation. We know that apply the electricity, it will have the strain caused by this equation, and then also for the thermal expansion, it will be also included in its deformation. And then for piezo question, we need to know is coupling matrix, and then also the stiffness matrix to solve for this question. The idea is simple. We have all the properties, the Young's modulus, Poisson's ratio, thermal coefficient, stiffness matrix, and so on. And then we just apply different voltage and temperature. So in the flux here, apart from the temperature and voltage, we just need to plug in all the information we said before, and then notice we should put the electric field in this axis because it will cause the least effect. According to this, because it's all affected by the z-axis, we want the least, so we don't want. So we just put the electricity field on the other axis. And then because it's 2D dimension, we want to get rid of all the z-related components. So for here, the thermal expansion, we get rid of all the z-related ones. And then to calculate the tip displacement, we put the equations here, this according to the formula, and then this one is to calculate the tip of the strip. And then for the boundaries, we want these strips to be 128 millimeter. So, and it's oriented at the origin. So it starts from the 6 for the piezo for the piezo ones. Here is the 6, and then here the -6 is symmetry. And then for the region 2, that's for the 2 plates. We start from here and then to the top, and then from here it start from the bottom, and then to the lowest place. So when we run this, is like this one. In the middle is the piezo, and then we can see this is the original one, and this is the exaggerated one. And we will have the tip displacement and the ratio between them. So we want to use the Python to do all the calculation to see a different range. So here we put the range set here, and then use the %s to replace the different numbers in the flux code. And we will also use the export to get all the numbers. And then for discussion, we see that we find the we find this.